So for today, we will discuss about the next topics. I will just write them just to follow them. So the first topic will be about interesting data that we can define in a class. So we will talk about constant and static attributes. And I will try to explain you when we need them and why we need them. Okay. We will also talk about memory leaks and the destructor. And they are kind of related. We can generate memory leaks frequently, but we can easily generate memory leaks if we don't implement the destructor. So we will see what's the class destructor today. And the last topic will be about the copy constructor. And here we will talk also about something more generic, which is called shallow copy versus deep copy, which means copying only pointer values versus copying values, deep copy. And again, all this stuff is available in all object-oriented languages. So if you understand their idea now, you actually understand how to use them and why to use them in Java, C# or any other object-oriented language. Okay, so again, all these principles are specific to object-oriented programming, and we just see them in C++. So in order to test all this stuff, let's take again the student class. I will just simplify the content because we need to focus on these topics today. So I will just get a name. And again, I showed you yesterday to your colleagues. Let's add another topic here. And this is remember, actually. Remember enums. Remember enums. Okay, so here I have the name of the student, and I want to manage the faculty of a student by using an enumeration. Why? Because the number of faculties is limited. But again, some of you may say, yeah, but what will happen if tomorrow in ASE, they will create a new faculty? What that will generate for us? So in that case, we need to come back here and recompile the source code because I need to add a new symbol in the faculty enumeration. So yeah, if you take into account something that might change in the future, an enumeration is not a good thing. So let's go for another type. Let's go for something which is standard. So let's say program type. And program type here, I refer to, there are different program types in ASE. You have the daily frequency or day frequency programs. So let's say daily. You have the remote or at distance, okay, daily. Yeah, I think it's okay. Okay, you have remote and or yeah, let's I think it will be much more clear to you if we go to the 3 standard programs that the university has. So program type here, I will go for undergraduate, which is the bachelor program, which is you, master, and PhD, because these are standards. In order to change this kind of programs, you need to change the entire educational system, which will not happen. So if you have values which vary between a limited set of values, and you know that these values will be constant in future, then you can have different options. So one option will be to go for an integer. One option will be to go for a string. Okay, and one option will be to go for an enumeration. Now, if you analyze all these types, you will realize that here for integer, maybe you can choose some associations. You can say, hey, undergraduate is 1, master program is 2, and PhD is 3. So you can use an integer, and it's easy to validate because here you'll accept only 1, 2, or 3. But the issue is that in time, you may forget easily what's 1, what's 2, and what's 3, because numbers can represent a lot of things. 2 can be, I don't know, 2 students. So it will be difficult to read the code. So integers are okay because it's easy to validate them, but let's say they are difficult to read. If you go for a string here, you can go for actually undergraduate. Okay, you can go for these strings. And in this way, the code is very easy to read. Okay, everybody will see the value master or PhD, and they know what they mean, what that means. But the issue with strings, and always remember this rule, try to avoid strings if you can. The issue is with strings is that they are very difficult to validate, because you see PhD in the human mind is also this value, and it could be also this value. And you got the idea, okay? It could be also this value, okay? PhD, because in the end it's still PhD, but it's written with different cases. So in that case, it will be very difficult to validate. You need to process the strings to lowercase to try to see what the user is trying to say to you. So strings are very difficult to validate. Try to avoid them. But if you are using an enumeration, and this is the way some of you saw that in C, okay, so here I will say program type. Okay, in that case, enumerations are actually a combination of an integer and a string, because if you remember, an enumeration, it's a sequence of symbols. So here I can say under or undergraduate. And I'm writing this with caps because you see our special symbols. They are not just normal variables. So that's why I'm writing them with caps. Okay, and we will write something else today with caps. Okay, master and PhD, because every time you see something with caps, with upper cases, it means it's special. Okay, it's different. You see here we are using Java mixed camel case, but for these ones I will use capital letters. Okay, so undergraduate, master. Now remember that by default these symbols are actually associated with numbers. So undergraduate, if you say, if I hover the mouse, is 0, master is 1, and PhD is 2. And you can easily change this because they follow this very simple rule. If you want to associate a different number, by default, they start at 0. And by default, this one will take the previous one value plus 1 and this one again. So that's why I have here 0, 1, 2. But if you want to change that, I can easily say undergraduate is 10, master is 20, and at this case, PhD will be 21, or I can say, no, I want to associate PhD with 30. Okay, so instead of using, when you are in this case, when you have a limited set of values for a variable, go for enumerations. Okay, they are much more flexible and efficient, and we will use them starting today because we will have this kind of scenarios. So instead of using an integer or a string, okay, instead of using this kind of stuff, I will go for an enumeration. Okay, and now the program type will be like this. So the enumeration is used like a type, program type, and I'll say here program. Okay, and that's it. So this value could be either undergraduate, master, or PhD. Okay, now you have the name, and now let's add the dynamic array because we need this dynamic array. And here I will say grades, and int number of grades. Okay, so today we will play with this class, name, program, grades, number of grades. Regarding what we covered last week, remember when you define a class, you should define also default values, because in this way you control what you will get by default. So empty string here, and let's say by default here, I want undergraduate. Now you can, I think you can write this directly, undergraduate, okay, and the compiler will identify where this symbol is defined, but I will always write also the name of the enumeration. Okay, so this is the style that I have. For me, it's much more clear to read this code rather than seeing undergraduate, because I will also see the name of the enumeration here. Okay, so you can use them directly like this, or you can use them by also using this prefix, which is the enumeration name. So I will use this style, but they both work. Okay, so for grades, because grades, it's a null pointer by default. It should be a null pointer because we don't have grades when you enrolled for the faculty. And here, this will be 0. Okay, so this will be the class for today. Again, remembering last week discussions, we get a default constructor. Here it is. So this is the default constructor. So every time you define a class, you get a constructor, you get this constructor, and now we can create a student. Remember that by default, everything here is private. So again, I will write this private. You also got a question in the today quiz. So which is the default? This is the default. So I hope this was an easy question to all of you. Okay, and we know that here we should define a public interface. Now, in order to test this kind of stuff, I will implement fast. So I will not go through all the get and set methods. We don't have time at any course, every course to implement those methods because we will lose a lot of time. But for today, I need this simple method, print student data.
Teacher, I have a question.
Yeah, please.
So about the program type enumeration, why do we need the numbers if we are going to write the whole name anyway?
Why do we need the numbers? These numbers?
Yeah,
here?
like you said, it's hard to validate if we write names. Like
yeah, if you have strings, because for enumerations, the source code will create the impression that you are using strings. You see, when I write equals undergraduate, I benefit from the same advantages of using undergraduate as a string, right? Which means it's easy to read the code. So you realize that the default program for all your students is undergraduate because it's like this. But when someone is trying to write anything here, for example, let's go back to the string program type. You see, I can do a mistake. Undergraduate, okay? Sorry for the typo. So by mistake, I can write this. No one will validate this because it's written by me. It's here in the default. Okay, so it's a typo. Now, if I try to do this with the program, okay, so let's see if I can simulate the same error. You see the error here. So if I will try to do the same here, undergraduate, okay, you see the compiler is saying, hey, what's that? I know that you should pass me a value from this, which means either this value or this one or this one. What's this? You see how you instantly know that you have a mistake?
Yeah.
So this is the power of enumerations. They look like strings, which it's okay because we like this. We can read this. Okay. But when you try to set the value, it's almost impossible to pass a wrong value because every developer which will do this mistake, the compiler will say, okay, it's a string. You can store whatever you like there. Who cares? It's a string. Okay, you can write anything. But when they try to do this and by mistake, they try to give us anything which is not here, they get the compiler error. So they are alerted instantly. So they will know instantly. Okay, now, even if you try to pass a number, so even if you try to pass here a number, let's say you know that PhD is 30, again, you see the compiler is saying, okay, let's say we know that enumeration symbol is associated with a number, but this is kind of a diplomatic way of saying, can you use the symbol? Because that's the idea. So don't write 30, because you see 30, and if I just continue talking and after that I will ask you, hey, do you remember what's 30? And you don't see the first line here, I think most of you will forget that 30 is PhD. So this is the issue with numbers. It's very difficult to remember later what's that, what's 30, what's 20, or what's undergraduate, it's 10, it's what. So that's the issue with numbers. So again, here, if you try to pass a number, again, the compiler is saying, yeah, it's okay with that number, but can you pass me a symbol here? So that's why let's say we will appreciate enumerations, because you see, it's forcing us to go on the only path which is possible by using the symbol name. And that will make the code much more easy to read because everybody will understand that this is undergraduate. Okay, so that's why. Yeah.
Are we obliged to use that program type before, like before the undergraduate?
Where here? No, I just said you are not. So you can write it directly like this. I just said that, but this is my personal style. Okay, so I will always use them like this, but you can choose between my style and this style. Okay, so my style will be this one, because if we have multiple enumerations, this will be one of my arguments. This will be helpful for developers. They will understand from which enumeration this value comes. Okay, so that's why I will write this. But again, you can use that. Someone asked in chat, can we typecast 30? We can't typecast 30 like we did with pointers, so you can't write this. Let me do this. But you can create your own function which will do that. So you can't say 30 and here to do a typecast. Okay, you can't say, hey, can you convert? Yeah, it's working. Can you convert 30 to program type? And in this case, I think it will, we need to check this one, but I think it will cast PhD. Okay, now let's see if we can cast a different value. You see, that's the danger with typecast, because right now we are trying to cast here 25, but there is no 25 here. And this will create the impression that we are actually casting the number to a specific symbol here. Now let's see what will happen. Build, rebuild, because we will create a student and we will print it. So we will try to see what we will get here. Debug, start without debugging. Okay, it's not crashing the program. So that's interesting. I'm interested to see what's the value there. So just leave this for a moment. Okay, and I will just print the info of a student, and we will see what value we got here, because here you see I'm casting a wrong number, which doesn't have an equivalent here. Okay, so we have the cout end line. Okay, the name, let's print the name, end line name. Okay, and this will be this name. Okay, cout end line, and here I will say program type. Okay, and here we will see the number, because remember they are numbers. So this program, and the last one will be the grades. And remember, we are setting null here because later I want to validate. So if the student has grades, if this grades different than null, it means we have some grades, because by default we don't. So let's print that. End line, student grades. Okay, for int I at 0, I less than this number of grades, I plus plus, and let's print them. Okay, so here I will have these grades at index I and a space there. Okay, so let's print the student, the default one. So here I will do student print info. Let's see what do we see on the program type. So build, rebuild. Okay, debug start without debugging, new share, and you see we get 25, and that's an issue, because maybe in the database we have that's an ID for another table where you have the program types, and this will be a foreign key, which means when you try to inject this in the database, the insert will crash because you failed the foreign key policy, which means the ID of the program type should be something that exists in another table. So you have a crash in the database. So that's why I'm saying that trying to cast this, is dangerous, because you can repeat the mistakes. So that's why let's use them with like here, undergraduate. And here I would say again, remember it's my choice here to write this undergraduate. So don't cast them. It's dangerous because you can place other values there and it will crash. The application will crash later when you will really want to use these values. Now, if you want to cast a number into an enumeration, or vice versa, for example, here, let's say here I want to see the program type as a name. This is something I did also with your colleagues. Then you can define here in your class. Remember, you can define any methods here. And sometimes maybe you want some methods which are just for you. Okay, so I will define this method private. So here I will say string, and here I will say cast program type. So I will make my own method. Okay, and here, or we can make this public. Yeah, let's make it public, because again, we are already on the public space. So let's call this one get program name. Okay, so you see each student now can return the name, get program name, and we can also have a program type, get program type. So you can have multiple get methods, get program type. Okay, and this one, it's easy, return this program. Okay, and here, in order to return the program name, I will do this switch. I will test the program. So this program, and let's write the cases here. So this program. Okay, and here I will say case undergraduate. Again, you can write without or with. And remember that for case, you need a break. But if you return inside the case, the function will terminate. So the break statement is not necessary anymore. So here I will return undergraduate, case master, return master, and case PhD, return PhD.
If I understood correctly, this is for the moment of cout like on console. Instead of a number, we need to want to have a name.
You want to see a name, right? Because if you run this now, the print info method, let me run it again and show you. So debug star without debugging, you see, I see the number. So this is the undergraduate. So maybe here I want to see the name. So in order to do the conversion between this 10 and a string, I need to write my own function. And this will be that function, get program name. So here I'll do this switch, and I will check which is the current program of the student, and I will return a string. Okay, so right now, if I want to see the program name, because now I have a function to do that. So program name, now I can say this get program name, and now I will call this function, which will return either undergraduate, master, or PhD. So build, rebuild. And if I do debug star without debugging, here it is. Okay, now I can also see the name of the program. Okay, but the conversion is done by me. And in the same way, you can write a function which will take a number, okay, and return the program type as the enumeration symbol. Okay, so you get a number, you do a switch, you test that number. If it's 10, you return undergraduate, the symbol, and so on. Okay, so in this way, you can do a conversion between integers to enumerations, or between enumerations and strings, like we did here. Because always when you print an enumeration symbol, it will print the number, because they are actually numbers. Enumeration symbols are actually macros. The ones that you have defined with define that symbol a number. Maybe some of you had done this like this. Define nmax, I don't know, 100. Every time you use nmax is actually 100. So these are actually macro definitions. This is the way they implemented them in C. Okay. So right now we have this class. We remember enumerations, and we will use them. Okay, I have the print info, and you see here that I got the default student, which means no name. We don't have grades, so that's why you don't see nothing here, because we don't have grades for that. So let's define a constructor for the student, which will receive all these values. And we know that we should validate, and we know that we should define set methods. So let's define set methods. I will define a set method here. So here we are talking about shallow copy versus deep copy, and why it's dangerous to copy pointers. Okay, sometimes you need to do that, sometimes not. So let's start the discussion on shallow copy. So here I will have this void set grades. Okay, and here I will receive, I don't want to change that integer array here inside the function. So const int integer array, let's say some grades. Okay, and here int number of grades, number of received grades. Okay, so generally let's validate to see if we don't get a null here. That will be a bad joke. So if some grades equals null pointer, it means it's giving us no grades. So why it's calling us, why it's calling set grades. So again, throw exception. Okay, no grades. Okay, and else, and I will remove the const, and you will understand why it's always better to write this const here, because it's preventing you, will prevent you to do mistakes. So let's remove the const. And now I will do this, this mistake, and this is shallow copy. And I will draw the memory to understand it better. So shallow copy, which means I will be naive and I will say this grades equals some grades. And after that, I will say this number of grades equals number of received grades. Okay, so now we have this this kind of stuff. We have this set method. Let's call it here. So let's define an array of grades. Okay, equals 10, 10, 9. Okay, and int number of grades equals 3. And now let's set this grades to this generic student. Student set grades of grades and the number of grades. Okay, so what is our purpose? Our purpose is to associate this student some grades, 10, 10, 9. So let's print this, let's test it. So here I will say student print info. So if this will work, it means it's okay. We will see some grades for the student. So build, rebuild. Okay, debug, start without debugging. Debug, start without debugging. And now if you check the output, you will see that the student without a name, okay, is enrolled in an undergraduate program, and the student grades are 10, 10, 9, which means it's okay. We can test this with another student. Let's do that. So I will just need to fix here the print info. Let's remove the end line. Okay, I want to see the grades on the same line. Start without debugging. Debug, start without debugging, and now they look much more prettier. Okay, 10, 10, 9. Okay, so let's try to test it with another student. And you know that if we have the set methods, we can also implement much more easier the constructor. So let's implement the constructor with parameters, with arguments. So let's say student, and I want the name for the student. I want the program type, program, and I will also want the grades. Okay, int grades and in number of grades. So I want to build a student with all the data that we can get. So here I'll say I don't have a set for names, so that's why I'm initializing this directly. This name equals names. This program equals program. Okay, and this grades. For this one, I will use the setter. Set grades of grades and number of grades. Now, some of you, maybe you checked tutorials or books on C++, and sometimes you have seen that here inside these functions, here, or here, some of the authors, they are not writing this. And this is actually possible. For example, here, I don't need to write this. You see, get program type will be return program. And the compiler will try to associate this with the program. And that's why it's working. Okay, so you may say, hey, so it's not mandatory to write this anywhere in the constructor. For example, here, can I don't write this? Yes, you don't need to write it. But again, this way is very helpful. So I will always write this, because for me, it's much more clear if I have a very complex method which is the attribute, which is the local variable, because if I see this, it's clear that grades, it's an attribute of the object. So every time you see this, you know, this is an attribute, it's not just a variable. And because sometimes you can easily do mistakes. For example, here, you see, you'll be tempted to reuse the same variable names here for the input arguments, name, program, grades, as the same variable names you use them here for the attributes. Now, when you don't use this and your habit is not to write this, you will do this mistake. You see, name equals name, and check the color of the variable. They have the same gray color. This is the same color with this one, which means this variable is actually this one, and this one is this one, which means you don't initialize the attribute. And this is called shadowing, okay? Because you are allowed to define local variables which will shadow the attributes. And in this case, the local variable takes precedence. Now, you don't have this issue here in the get method, because here you don't have a local variable called program. And now the compiler says, hey, this is the program, the attribute. But you see, in functions which receive input arguments, if you reuse the names, then you are in danger of doing this mistake. Let me show you what's the effect of the shadowing. And that's why I will always write this. Now, you can write without this. It's your option. But if you do this mistake and you lose points at the exam, or you fail the exam, that's your responsibility, okay? So use them wisely. Okay, so let me show you what's the issue here. Now, you see, when I have defined the constructor with arguments, this is again from last week. Now the default constructor is not available. It's saying it does not exist. So if you still want to provide the default constructor, even if I recommend you not to, or to make it private, you need to redefine it. So now you need to define it explicitly if you still need it here. So I still want this code to work, so I have redefined the default constructor. So let me show you what's the issue with shadowing. You see, you don't get any compiler error. I think you get a warning. Okay, let's see the warning. No, I don't see even a warning. Let's do a build rebuild. Okay, I don't see any warnings. Yeah, I don't see any warnings regarding this error here. So let's try to build Alice, to create a student named Alice. So here, after this generic student, I will create Alice. So student Alice, the name is Alice. Program is again program type, let's say undergraduate. Okay, undergraduate. And I want to pass the same grades as the no name student, the nameless student. Okay, number of grades. And now let's print Alice. Let me show you what's the effect of shadowing. So if I will say Alice print info, okay, and hit build, rebuild, and I will run this. Okay, so debug start without debugging. Let me show you debug start without debugging. Here is what you see. Okay, where is the name? Okay, you don't see the name, because we are not initializing Alice. So this is a side effect of shadowing. You are not initializing the class attributes because that variable is the input argument. So you will not see that value here. Again, I see the 10 undergraduate, and I see that Alice has the same grades as the nameless student, the John Doe student. Okay, which means the set grade works. And you see how that error, it's remain hidden. So let's fix the shadowing. So shadowing, this is shadowing. And that's why I will always write this. Okay, I made a lot of shadowing mistakes, and I don't want to repeat that experience, because sometimes it's quite difficult to see this error here. You just search through your functions, trying to figure it out, where is your name of the student. And the issue, it's right here. Okay, so let's add also this topic here. So that's why I'm writing this. Okay, so you can choose not to write this, but watch out for errors. You will be responsible for those. Okay, I will always write this in my examples. Okay, so watch out for shadowing. Okay, it's easy. And you have the shadowing problem in .NET and Java. Again, it's a common error in those languages. Again, if you write this a lot of people will appreciate. I will always appreciate that because it's easier for me to read the source code. I instantly identify this variable as the attribute of the object, because when you say this arrow, it means you follow that by an attribute or a class function. Okay, so we still have a issue, and you see it's hidden, and this is the danger with shallow copy. At this point, we have 0 compiler errors. So you see we have a hidden error, because if you check the compile list, there are no errors here. And if I will run this, okay, and you see the output, you may all say it's working. We have Alice, we have these grades, we have the nameless student, it has these grades. So it's working, right? Where is the issue? And just keep in mind, we have an error, and I will show you when this will pop up, because it will happen much more later. And the first thing you will try to search is the function you wrote there, because you will think that at this moment, if this program works, it means it's correct. And after that, you add something and the program will crash. Obviously, the first candidate, the first thing that you will inspect will be that thing you just added, because after that, the program crashed. Okay, so let's leave this open question. So the question before the break was how this will affect us, how this shallow copy will affect us. You see, we all have this feeling that everything is okay based on the output. So let me show you when this error here, and because we call the set method in student, it means also the constructor has an issue. So you see at this point, we have 2 methods with the same issue. Set grades, which is the one that creates the problem. And every time you call set grades, you have the same issue again. So let me show you when that will happen. For example, let's define here a method which will allow us to change 1 grade. Okay, so here I will say void, and let's say this is like a student goes and retakes the exam. Okay, maybe takes the exam again in order to increase the grade or whatever. So let's say retake exam. Obviously here normally we should have also a list of a vector of strings where we record the name of the exam for that grade. So in this case I will say give me the new grade, and I want the index. Okay, so I need the index of the grade that you want to change. So retake exam, let's say. So in this case, I will always validate. So again, let's validate. If index is less than 0, or index is bigger than the number of grades that we have, it means number of grades greater or equal. Remember, the index starts at 0 to n-1 in C and C++. So if that's the index value, it means it's wrong. So throw exception wrong index. Okay, because it's either negative or it's outside of our array, wrong index. Okay, now if that's not the case, if that throw will not execute, then I will say this grades at index equals new grade. So now I'm changing the grade for any student. I can change a single grade of a student. Okay, let's also set a set name, because I want to change to set a name for that student. So void set name, just to name John, string name. Again, here, if you write this name equals name, this is again shadowing. So watch out for this stuff. So this name equals name. So now we can change it a grade. Let's see what will happen. So let's name John, student set name John. Okay, so now we have a name for this student. And now let's change John grade. So let's say John goes and retakes an exam, and the final this grade here will become a 10. So student retake exam, the new grade will be 10 and the index will be 2, right? 0, 1, 2. So now let's print John, student print info, and let's run this build rebuild. Okay, debug start without debugging, and here it is. John has 10, 10, 10. So he will get the scholarship. Okay, so we actually change the third grade of for John. Now let's have the curiosity and check Alice's grades. So Alice, print info. Okay, so normally Alice will have the same initial grades, right? 10, 10, 9, because that's was her grades. Let's see. Build, rebuild. Okay, debug start without debugging. Let's run this again. Okay, and here are Alice's grades. 10, 10, 10, which I think is not okay because we change John grade, but not Alice grade. So why now Alice has the same grades as John? Because she actually literally has the same grades as John. So why is this happening? And this is actually shadow copy, okay? Shallow copy, sorry. Why is this happening? Because of this. So if I will draw the memory of our program, just to understand why this is happening. And this is the danger in java.net. So if you understand the danger of shallow copy, you actually will do less mistakes in Java. Okay, let me share the whiteboard with you. So we have these two students, okay? So this was initially John, okay? And later we have created Alice. And besides a lot of things here, besides the name, so it's here John, and here we have Alice, we have also inside each object, we have a pointer, which is the grades pointer. So each object has its own pointer, grades. And at some point, we have created on the main stack an array of grades. Here it is, that initial array with 3 grades, 10, 10, 9. And we have also the number of grades here, which was 3. And again, each student has its own number of grades variable here. And also they have the program type, which is another number. Okay, so the program type will be also here, the green box. Okay, now we have a method called setGrades. And remember, all arrays are managed by pointers. So let's suppose that the address of this array here is A, and all these pointers were initially not. So we have a method called setGrades, and here it is, setGrades. And we use the same setGrades here in the constructor for the student. Now, if you go back and check what setGrades is doing, like here, you see it's saying these grades equal some grades. So when we have called for Alice, when we have called for student set grades, and this is John, set grades of grades and number of grades, it means that we are jumping the execution here, and this is actually John, and we are saying the pointer grades from John takes the same value that we receive here, which is another pointer, you see it? And that pointer is actually the pointer of this array grades, which means that when you call set, John here will get the same address. This means a pointer again equals another pointer. You just copy the address from one pointer to another, which means now John points here. So that's why when we have printed John grades, we have seen 10, 10, 9. After that, we have created Alice with the constructor, and in the constructor, we are calling the same set grades, and set grades receives the same pointer from main, 10, 10, 9, which means Alice has the same address, which means this pointer points to the same array grades, okay? And that's why if we change any of the values from here, like we did for John, we are actually changing the grades for all the students, which we have created them in this way. And this is the danger of shallow copy. You see, shallow copy creates the impression of a copy, but it's just shallow. It's just an impression. We have believed that we actually copied this array for each student, but actually we are sharing the same physical array. So every time you change something here, or even worse, when we will delete this array, these two students will be without grades. These pointers will point to something that does not exist anymore, and the application will crash. So what will be the correct image What's the opposite of shallow copy? What means each student has its own array? It means that when you try to copy these grades for Alice, we need to create, obviously in heap, a new array. And here we need to copy the values from what we pass here as an argument. And this address, let's say B, should be here, okay, B, which means Alice will have its own array of grades. And this should also happen for John, and actually for each student. Each student should have its own array of grades. Because if we accomplish this, it means that every time you change the grades for a student, you change them only for that student. All the others are not affected. Okay, so this is the image that we want to get. This is the image we have. And this is shallow copy. This is deep copy. We need to create different arrays for each student. So always do this, especially with objects which receive pointers. And that's why we don't do that, okay? Equals some grades. So how do we create this image? How do we create a new array for each student? So each student will have its own grades. Okay, it's easy. Here I will say this grades equals new int of number of received grades. Okay, for int I, or you can use memcopy from C, I starting at 0, I less than number. Watch out which variable you are using. Okay, so use this one or use this one, but in that case you should move this line here if you want to use number of grades. Okay, so watch out not to mess up the variables. Okay, and here I'll say these grades at index I equals with some grades at index I. Okay, so by doing this change, now we have deep copy, which means we copy the content to a different array. If I rerun the program, I don't need to change the constructor. This is also the benefit of using set methods, because if you have a mistake in a set method, then if you fix it, you fix all the functions which are calling set, including the constructors. Okay, start without debugging. And now we should see that Alice is not affected by the fact that John has retaken an exam. You see, Alice still has 10, 10, 9, and only John has a new grade here on the third value. Okay, so this is one of the dangers of a shallow copy. And you see, the error will remain hidden for a long time. You will have no idea when you have actually created this error. And sometimes maybe, let's suppose that we didn't print Alice here. Maybe we jump to another idea and maybe we will print Alice, I don't know, in 1 week from now. And in the meantime, we will implement other functions. And at that point, you will try to figure it out why Alice has other grades. Because you see, the error has been created today by doing the shallow copy. So watch out when you copy arrays, okay? Sometimes we may want to do this, but let's say only 1 or 2% of the cases. But in many other cases, we need to create a new array, okay? And you see, this is actually the same discussion we had with get. Don't return a pointer. We had this discussion 2 weeks ago, and I showed you that you should return a copy of your array, because if you give me your address, I can change your grades. Okay, and this is actually mirroring the same scenario for the set methods. So when you receive a pointer, don't do shallow copy. Okay, so this is the shallow deep copy. Now, we still have an issue here. And let me show you. And now we dive into what are memory leaks and how they can affect us. So you see here, we have this set method, set grades. And if I will go here, okay, let me show you something. I will do an infinite loop. Okay, this is an infinite loop. Okay, so this is an infinite loop. And here, I will actually change the grades of John forever. So I will do this. Student set grades. Okay, and here I will say grades and number of grades. Number of grades. Okay, so let's try to do this forever. Okay, so build, rebuild. Debug start without debugging. Okay, now the program is running, but I want to show you something else. Let me show you something else. This is my task manager. You see this application? It just reached 2 GB of memory. Let me run it again. Now it has been terminated. You see exit code 3. Let me run it again. Just 1 second. Just watch the task manager. Okay, so debug start without debugging. Okay, and you are watching the task manager. Just look here. You see it? 19, these are gigabytes. 19, 2 GB terminated. So this very simple application has reached in a matter of seconds 2 GB of RAM. Now let me show you what will happen without this. So build, rebuild. Okay, debug start without debugging. Again, the program will run and terminate, but let me show you what's the normal level of memory that this program will require. So I will uncomment this one and I will just do this infinite for without the set grades. So let's run this infinitely without set grades. So build, rebuild. Okay, debug start without debugging. So this is running forever. Let's check the task manager again. And let's see what's the level of memory that course07.exe requires. You see, it's stable at 0.5 megabytes, which means normally this program will require half of a megabyte. Okay, but if I do that set grades forever, this memory will reach out 2 GB and Windows 10, Windows 8 will instantly terminate that process, because otherwise the operating system will remain without RAM. Okay, so why it's happening? Why doing this infinite set grades will require a lot of memory? You may say it's related with student. Okay, let me show you something else. Let's do this infinitely. So I will just change the name, not the grades. So build start without debugging. Yeah, the exe is still running. 1 second. Build, rebuild solution. Okay, debug start without debugging. So again, it's running forever. Let's check the task manager again. So if I go and check the task manager, here it is, course 07. Again, it's stable. So it's running forever and it requires only half of a megabyte. So changing the name has no issue, but changing the grades will make this program in a matter of seconds to reach 2 GB of memory. So why is this happening? Let's go back to the drawing board. Let's see what set grades is doing. Okay, so this is the set grades, and especially the reason is here when we do the deep copy. If I go back to shallow copy, the program will be stable again. So you will say, so, deep copy is the reason. If we do deep copy, we will run out of memory. No, deep copy is okay. We have another mistake here. So when we call that set grades again and again, we are actually doing this, okay? So you have John, and initially John has no address here. When we call set grades for the first time, we get this address C, and we get 10, 10, 9. And after that, we call set grades again with the same values, okay? So here we will call set grades again with the same array. But the function will do what we program it to do, which means we'll do this. This grades equals new int. What it means? It means every time we run set grades, we get a new array at a different address. This is new, D. And here we copy those values. So this is the second time that for loop will run. The third time, again, we get another array, E. And here we get 10, 10, 9. And this will go forever. So at every iteration, we are actually creating an array in heap, which has 12 bytes. 12 bytes, just 12 bytes. It's quite small. But we do this with a very high frequency, like millions of times, billions of times per second. So what do? This grades equals some grades, and here we keep the new address. Okay, so every time this pointer from here will take the new address, the next time, the second time will be D, the third time will be E, and the story will go on forever. Now, the question is, what's happening with the previous arrays? What's happening with them? Every time you create a new array and you leave the previous one in memory, nothing happens. They are just staying there. Remember what I told you. Every time you create something with new, you are the only one responsible to release it with delete. No one will delete that for you. And that's why we love heap, because it's not like on stack. When the stack, the function is terminated, you lose the stack. No, here you don't lose anything. You create something in heap, it will stay there until you decide to be deleted. So what's happening with all these arrays? They are left in heap. 12 bytes, 12 bytes, and this will go on millions of times per second. And these 12 bytes, they are just piling up until this program will reach 2 gigabytes of RAM very fast. So where is the issue? The issue is we forgot to clean up the previous array. So the other conclusion of the day, every time you change the address of a pointer from an object, every time you do that by creating a new array, it's your responsibility to clean up the previous one, because otherwise the previous array will be left in memory, and that will be called a memory leak. So what's a memory leak? It's like you have less and less available RAM because you create a lot of values in heap, which you will never reuse because you lose their addresses, and they are just staying there. No one will delete them. And this is a memory leak, creating something in heap and losing the address. Why do we say we lose the address? Because you see, the nth time you run that for, you get a new address here in the pointer grades from John. Now, what's happening with the previous address? You lose them because you don't know where the previous arrays were at C, D. You don't have those addresses anymore, because this pointer here can store only one address. So when you lose the address of something in heap, then you create a memory leak. So let's not create the memory leak. So if I go now in here in the set method, let's avoid the memory leak. How do we avoid the memory leak? When we know that we will create a new array, and this is the moment, when you see a pointer equals new, it means you get a new address. When you know that that will happen, we do this. If this grades is different than null, which means if this pointer has a valid address from other actions, then delete that array, because we will just create a new one. Okay, and this is the way you call delete in order to destroy an array. And delete has this very simple rule. Just remember it. What is created with square brackets is destroyed with square brackets. Later this semester, we will create objects in heap. So we will not use new and brackets. And for that particular object, we will delete it using just delete. Okay, so remember the rule. Everything which is created with square brackets, like new square brackets, is deleted with square brackets, and don't write the size here. Okay, the system will determine what's the memory size there in heap you want to remove. Okay, so don't write any size here. Don't write it. Okay, so if I do this now, let's see if the program is still running. Build, rebuild. Debug start without debugging. And now if we will check, you see it's still running. It's running infinitely, but nothing bad has happened with the John or Alice grades. run again infinite times set grades. Let's see if now the program will reach 2 gigabytes as before. So debug start without debugging. It's running forever. And let's check the task manager. So if I go to the task manager, you see, it's stable at 0.5. Why? Because we are not creating any memory leaks anymore. Okay, so these are memory leaks, and this is the way we avoid them. Every time you change the address of a pointer, just ask yourself, hey, do I need that value anymore? Do I need still to keep it in heap? Or it's safe to delete it because I will get a new array? And if the answer is no, you don't need to keep it, then you should avoid the memory leak. Okay, so that's a memory leak, and this is the way we avoid it. Okay, now let me show you another memory leak, how easy it is to create another memory leak, and let me show you again how we can fix that. So remember that our objects, this is John, this is Alice, they all have a pointer which points to the grades of that student. Okay, so we have this pointer here in John, now Alice here. We solved the shallow copy problem, so each student has its own grades. Let me show you how this program will crash again by running out of memory. So I will do here infinite times this. For, again, an infinite loop, student, Bob, okay, what was the next one? Let's see, the program type. So let's say Bob is a master program, and Bob has the same grades and number of grades. Okay, so right now we're creating infinite times Bob, and because this is a local variable to the for loop, it means Bob will be instantly destroyed. Or if I want to make this even much more obvious, I will say this. Let's create Bob in heap. So this is the pointer to Bob equals new Bob, new student, sorry. Okay, and now the student is created in heap. Okay, so earlier Bob was on the main stack, now Bob is in heap. How do I know? Because I see new here, and this is a pointer to a student. So, and after that, obviously you will say, yeah, but it's obvious here you create memory leaks, because you will create an infinite number of students in memory, and that will eat up all the available memory. So delete Bob. Okay, let's delete Bob. So we do this infinite times. We create Bob and we delete Bob. Remember what I told you, everything you create with square brackets is deleted with square brackets. Now here I'm creating only one student. This is not an array of students, it's just a student. So I will delete Bob instantly. So it means that if we are creating the student object and after that we delete it, we will be safe, right? We can do that infinite times. So build, rebuild. Okay, let's stop the program. Build, rebuild. It was still running in memory. So I have 0 errors. Debug start without debugging. And again, let's check the task manager. And here it is. You see, it's not increasing so fast, but it's increasing. You see it? 153 hundreds of bytes, 197, 200. If I just wait 5 seconds or 10 seconds, it will reach 1 gigabyte. It's just going up, 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 up. And when it will reach 2 gigabytes, it will be terminated by the system. So it's obvious. When you have a program which is just eating up memory, it means you have a memory leak, and this will be the effect. Okay. Now, in reality, you will not have an infinite for. So you will not realize that you have memory leaks. But if this is a server and is running for months, at some point it will crash. Now here I'm just forcing things up to reveal themselves by doing the infinite loop. So the infinite for is just revealing the memory leak. You see how it's constantly going up in terms of memory. So what's the issue with that? So why this is just going up? Okay, so where is the memory leak? Because we fixed it in the set. So we are not creating, let's say, we are not creating the memory leak in the set method. Now, let's think what we do here. So we do infinite times this. let's go back to the drawing board, which means infinite times we create a student like this. So we are in heap here. Okay, this is heap. So infinite times we are creating Bob. This is Bob. You have a box. This is Bob box. And Bob, in terms of size, has a size. You had the question. And remember, if you just add the number, the types here, you get the size of Bob or any student. So let's see, what's the size of Bob? The size of Bob is, you have a string here. Okay, let's say it's a string. I don't know, some bytes. You have a pointer here, which is 4 bytes always. And here you have an integer, which is 4 bytes. So the size of the Bob student is actually 4 plus this string here. Let's suppose this will be Bob. So it will be 4 bytes, okay, because it will store Bob and \0. So actually the size of Bob is the size of the name Bob. It's a string object. And you have another pointer here, which is grades. You have the program type, which is another integer. Remember, enums are actually integers. So this is the enum. And here you have the number of grades. So actually we can say it's 12 bytes plus the size of the name, plus 4. So it's 16 bytes. This is Bob. So every time you say new student of Bob and the arguments, we are creating this in memory. And after that, we delete it. So where is the memory leak? You may say, so you are creating 16 bytes, and after that, you delete those 16 bytes. So where is the memory leak? What do we have here? What's this? This is a pointer for Bob grades. And initially here we have 10, 10, 9. Now, when this object is destroyed, what do you think? Is anyone smart here, the operating system, to actually delete the array? Or they are just deleting Bob, only this box? What do you think? Is by default this array deleted, or they are just deleting the Bob box? Let's take this logically. If this array will be deleted also, the grades, okay, 10, 10, 9, it means we don't have any reasons for memory leak. But if this array is not destroyed, then this is where you have the memory leak. And this is actually what will always happen. So another conclusion of the day is, if you have a pointer in your class, and we will always have a pointer in our classes. So sometimes you have this question, what do we get for the exam? We can actually establish a rule. You will get for the exam a class which will have at least one pointer. So that's 100% sure, and it will never change. So if you have a pointer in your class, you see it? And for this pointer, you allocate space in heap. This is where we do that in set grades, where it is set grades. Here is where we allocate it. It's your responsibility to destroy that space when the object is destroyed, when Bob is deleted. Now, the big question is, how do we know when the object is destroyed? Where is the function? So all the classes that we will do, they have a special method, which is called the class destructor. And because the class destructor is only one, so you have only one class destructor, there are no many class destructors. There is only one function, which is called the class destructor. And because it will be used to destroy objects, not to create objects, again, it has a very special name because it starts with this sign. And the name of the function, again, is identical with the name of the class, and it doesn't have arguments. So this is the class destructor. Okay, so what's the role of the class destructor? Generally here, we release the space from heap where objects store data, which means you have a pointer to something in heap. So what's the space which each student will manage in heap? The grades. This is it. So who is responsible for deleting this array when the object will be destroyed? Remember, everything that you create in heap, you are the only one responsible for deleting that. the operating system, the compiler. No one will do that for you. So release that space. So if these grades different than null, then delete grades. Delete these grades. So this is what we will do in the destructor. Okay, null pointer.
So this destructor destroys automatically the object, but we have to add as an argument this in order to delete the vector, the array.
Exactly. So you have by default a destructor, like you had the default constructor, which automatically will destroy this box with all its variables. But you see, if you have a pointer here with an address pointing to something in heap, they will never destroy that. So it's our job, because we know the structure of a student class. We know we have something in heap for each student. We have some grades or other values, but in this case, just the grades. So it's our responsibility to actually delete those. So that's why we need to write the destructor, not to destroy the box itself. This is still done. We don't care about that, but to do something that the default destructor will never be able to do this. So by implementing the destructor, and you see, you don't need to call it. Okay, I don't need to do something special here. So every time an object will be destroyed, like in this case, you see I have delete pbob, which means I want to delete the object in heap. So right now the destructor is called. So in order to prove that to you, if I print here, maybe we'll retake this discussion next week. So if I print here cout end line student destructor, okay, you will see this message infinite times because we are doing that infinite times. So build, rebuild, okay, and now debug start without debugging, and this is how my output looks. But again, if I open the task manager, we don't have the memory leak. So you see, even if I don't even see where is the, yeah, here it is, course 07. You see, again, it's stable at 0.5. Okay, so it's not going up anymore and it's running forever. Okay, so that was the memory leak. Okay, it's still running and creating the object and destroying the object, that object. Okay, so this is the issue with C++, and that's why it's much more difficult to learn C++ rather than Java, where you have a garbage collector. My colleagues will explain to you what's that. You have a big brother which is cleaning up the space for you from heap, because you have a virtual machine. But in C++, there is no virtual machine. You are alone, and you are responsible for all the stuff that you will actually do. So it's our responsibility to clean up after objects. So that's why we will always define the default, the destructor, every time we have a dynamic something in our classes, every time we associate some values in heap. Okay, so that's why I need this. Now, in order to end the discussion, so the copy constructor will be left for next week.
I have another question about this destructor.
Yeah.
Why do we only delete the grades when there is also created the name, the program type, and
because these are created here in the box, in the student box.
Also, even if we have all of them in new student,
they will be automatically deleted. So by default, the system will delete the bob variable, which is this box where you have what? The name, the pointer, just the pointer, the number of grades, and the program type. So this box will automatically be deleted. But we also have the array here in heap.
Okay, yeah, because it's a pointer, it's an array, and
yeah,
it's another space. Yeah.
Yeah, exactly. It's not here. It's not in the box. Now we can reach this anytime, right? Because we have the address here in the box. But you see, when the system is destroying the box, they don't follow pointers. So pointers are our responsibility to clean up if you have here something.
Yeah.
Okay.
Thank you.
So that's why we need the destructor. And just take it as this simple rule. If you have a dynamic field there, it's your job to clean it up. Now, in order to end the story, for example, here, just I want to introduce static variables because we will use them. For example, let's say here we have an age. We have age. And this is one way to use static variables. For example, age. And let's suppose we have a set age. And you have seen we validate it. Okay, so set age. And here we say new age. And here we say, hey, let's suppose the minimum age is 10 years old. So if new age, let's say new age is less than 10, or new age is greater than, I don't know, 90, then again, we throw an exception. Throw exception, and let's say wrong age. Okay, wrong age. Now, I told you that these numbers which we hard code them here are called magic numbers, because from time to time someone will ask, hey, what's 10, what's 90, what's that value? That's why they are called magic numbers. They could be anything. So in order to avoid them, we as humans, it's much more easier for us to interpret them if you see here a variable name. So right now you will say, let's define this: int mean age equals 10, int max age equals 90. So when I do this, obviously here I can say mean age and max age. And now I think it's much more easy to read. Now, the issue with these local variables is that they are local to set age. So if another developer will try to validate age in order to use mean age and max age, they can't, because they are hidden here in set age. They can't access them. So we want to make these variables available to others. So in order to do that, obviously we need to define them here at class level, because if we define them here, others can access them by a get method or directly if they are public. But if I define mean age and max age here, okay, in the class, it means that each student should have these two values, which is wrong. It's like you need to know which are the rules at any time. You need to know which are the rules of the faculty. So how can I define these variables without defining them global, which we said we will never do that, like here. So these are globals. We will never do it. How can we define them so they will be related with the student, because we can have mean age and max age for a professor and other values for a student, but without actually saying to the student, hey, you need to know which is your minimum and maximum age. So we will define them here inside the class, but in order to say to the compiler, hey, these are related to the class, but they are not related to the student itself, which means they don't describe a student and they don't describe one of its values, but they are related with the story of a student, we will define them static. And static variables, you see, they have this very strange rule in C++. You can't initialize them here. And the only way to initialize them is to go outside the class. And this is quite strange, but there is no other way in C++. I will show you that, but there is no other way. So if I go here, I need to go outside the class. I need to redefine them without the static. And now the compiler will say, hey, these are globals. And now I need to say, no, they are not globals. They are static variables from student. You see again the syntax that we have seen for enums. So now I can say this is 10 and this is 90. So at this point, I have defined something which is very close to global variables, but they are not global variables. And these are the static variables. So static variables are variables which are related to your class, but you don't want to make your objects to store those values. So those two values are stored somewhere here. This is mean, this is max. So students will not carry those variables because it doesn't make any sense, okay? So a student still has a name, grades, program type, and number of grades. And these are the two variables which exist only once in memory. But this is very useful because now other developers can actually check them. So if I'm another developer and I want to see which are your minimum value, I will say this: cout end line student mean age is student. And you see, I don't see them because they are private, and I will show you how to define static getters. But if I make them public, because you can read them, okay, if I say student mean age, now I can access it. Okay, so every time we will define some validation limits, we will use this approach. We will define static variables here, and we will use those static variables every time we want to validate. Again, here you see it's like with enums. You don't need to write student each time. Okay, so now it will be like this. So right now we can share these values with others, because others can now validate. For example, our colleague, which is managing the input, the console. Okay, so this is one way to manage those values by using statics. Okay, so that's all for today.